Good morning, students. First of all, today I wish to discuss about the general quadrature formula. In equidistant interpolation, the relation between x and n may be expressed like this. For equally spaced data, x is equal to x naught plus nh and dx is equal to s times dA, where h is equidistance. Okay. So by using Newton forward difference interpolation formula over P with bit h, we may write this equation by using Newton forward interpolation formula, that fx is equal to f naught plus n times del f naught plus nn minus 1 by factorial 2 del square f naught plus nn minus 1 n minus 2 by factorial 3 del cube f naught, and so on. So now the above formula may give this result: x naught to x naught plus nh fx dx is equal to, after some simplification you will get, you may be in the position to write this formula, that is s times n of f naught plus n square by 2 del of f naught plus n square by 3 minus n square by 2 del square f naught by 2 plus n power 4 by 4 minus n cube plus n square del q f naught by factorial 3, and so on. From this general formula given by Newton and Cotes in combination, we may obtain the distinct quadrature formula by putting the different values of n. If you put here in this formula n is equal to 1, then you will get trapezoidal rule. If you will put n is equal to 2, then you will get Simpson's 1/3 rule. And by putting n is equal to 3, you will get Simpson's 3/8 rule. So this is the parental formula of all the numerical integration. This is only 3 I am discussing, but there are many. Why I am discussing only 3? Because that is in the course of all the engineering students. So now do one numerical problem. In one problem you apply all these methods. How? Just to try to learn. 0 to 1 dx 1 plus x square. This may be any definite integral, any kind of definite integral. And you have to apply using trapezoidal rule by taking h is equal to 1 by 4, Simpson's 1/3 by taking h is equal to 1 by 4, but Simpson's 3/8 by taking h is equal to 1 by 6. Then the value of fx 1 by 1 plus x square are both cases, because here the distance is already common distance, means space is common, h is equal to 1 by 4. So for A and B, you can use this table, Ex and Fx. Fx is what? 1 by 1 plus x square. So now putting the different values up, and this is 1 by 4, bit is 1 by 4. The distance between this and this is 1 by 4. Here is 1 by 4, here is 1 by 4, here is 1 by 4. So this is equally spaced data. So after putting the value here, you will get, this is what? Y naught. This is what? Y naught. The value is Y naught. Here this is Y1. This is Y2. This is Y3. Y1 is 0.9412. Y naught is 1. Y2 is 0.8000. And then Y3 is equal to 0.6400. And Y4 is 0.5000. So 0 to 1, just to use the formula h by 2, as I said, the formula is the first argument, means y naught. So y naught plus 2 times, and then y1 and plus y2. So y1 plus y2 and so on, except last term. So y1, y2 and y3. So just to check, y1 is 0.9412, then y2 is 0.800, and then 0.6400, that is y3. And then last is 0.5000, that is y4. So first ordinate y naught, this is the last ordinate, and in the between two, y1 plus y2 plus y3. So now after putting all the values, you will get 0.7828 by using trapezoidal rule. If you are using Simpson's 1/3 rule, then the formula will be changed. Formula will be h by 3 and 1. 1 is for y naught. Y naught plus 4 times. 4 times what? Y1 and plus y1 plus y3 odd ordinate. The odd ordinates are only 2 odd ordinates. One is y1 odd, this is odd ordinate, and y3, this is also odd ordinate. Okay, so y1 plus y3 plus 2 times even ordinate. Even means this 0.8000. This and last ordinate means 0.5000. So again here you will get the value 0.7854. Just you look the technique. 7828, but here 7854. The value is different. Now if you want to use the Simpson's 3/8, but since the space is 1/6, So we have to construct the first table. How? The value of fx for this case c is x and fx. Fx is again the same 1 by 1 plus x square, but here the difference is now 1 by 6. Here this difference is 1 by 6 everywhere. So you take the equally spaced data means 1, then here you will get 0.9730, 0.9000, 0.8000, 0.6923, 0.5902, 0.5000. With the help of your calculator, you can check it, recheck it before using. So now you use the formula 3h by 8 and first and last term. This is the first term, y0, and this is the last term, that is y. You check y0, y1, y2, y3, y4, y5, and y6. So this is y6, the first and last term, and then plus 3 times. 3 times is the multiple of 3. Multiple of 3 means this is y3. So this is y3. Okay. So y3 is sorry. This is y2. Y2 to all other term. So all other term means this is y2 and y2 plus y3, and then this 0.y4, and this is sorry y1, y2 except 3, except multiple of 3. So this is y1, this is y2. You leave this y3, y3 you leave. So except multiple of 3, all other term 3 times. So 3 times this and plus 2 times this term 0.8 means multiple of 3. So multiple of 3 is only one term. Here you write 0.8. Now after calculating these values, you will get 0.7841. Just to imagine what is the difference. Here the technique is 0.7854, 0.7828, and in the last, by just changing the space and by changing the rule, you will get 0.7841. The problem was one, but the answer due to the technique and the space, that is different. Okay. So in this way you have learned how to use this formula. Now these are the questions for practice. The velocity of v of a particle at a distance and from a point on its path is given by this table. S is the distance and v is the velocity. Feet, distance is in feet, and velocity is feet per second. That is 0, 10, 20, 30, 40, 50, 60, equally spaced 47, 58, 64, 65, 61, 52, and 38. Using Simpson's 1/3 rule, find the time taken by a particle to travel 60 feet. So this is the problem. And second, calculate 2 to 10 dx by 1 plus x by dividing the range into 8 equal parts. Here I have not restricted you the method. You have to decide what should be the efficient method to calculate this integral, numerical integral 2 to 10 dx by 1 plus x out of trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. Thank you very much. Thank you. Stay safe. Thank you.